So every year when I introduce this topic of hybridization, and I tell students that all you literally have to do is draw and label flower petals, people look at me like I'm crazy. But by the time I'm finished, you're going to understand exactly what I mean and how simple and how easy this is. Okay? Now, there is a little bit of content knowledge that you need to remember from the previous unit that will make this be a whole lot easier. Okay? So there's 3 questions I need the answer to. Does anyone remember how many s orbitals there are? There's 1. There's only 1 s orbital. Okay? Just 1. So you remember how many p orbitals there are? There are 3. And I know it's like, why are you doing that? It'll make sense. You want to remember how many d orbitals there are? There are 5. So this is what is going to get us to be able to understand hybridization. And I know, like, what are you doing? And I promise all this will make sense. So here's the first one I want to do. So we've got to do the hybridization. I'm going to skip the very first one, and we're going to look at CBR. Now, I know I'm leaving the dots off around the BRs, but I'm doing it just for space and time. But they should be there. All right? So every one I do, mentally and sometimes physically, if it helps. Ma'am. Good question. It's this one. The one with all the boxes on it. Yes, ma'am. So the first one we're doing is CBR4. All right. Trinity, sir. Will you pass that back? What color flower do you want me to draw? Green. Green. Purple. Light purple. All right. So we're going to go with light purple. So here's the most important part about all of this. Now I hope this is like, actually that's not light purple. That's light purple. Sorry. The most important part about this is you have to recognize, what do you draw a petal around? It's 2 answers. It's a bonded atom or an unshared pair. Around which atom? The central and the central only. So who is the central atom in this molecule? Carbon. So are there any atoms bonded to it? How many atoms? 4. Are there any unshared pair around carbon? No. So this flower is only going to have how many petals? 1, 2, 3, 4. Now, then, once I've got my flower petals drawn, I then have to label it. So here's how I label it. I come in and I say, this is S, and I mark it off. Then I have another one. This is P, and I mark it off. Do I have any more? Keep going. This is P, and I mark it off. Do I have any more petals? Label it again, and this is P, and mark it off. Are there any petals unlabeled? So here's the hybridization. That's the final answer. That's it. So all you do is draw a petal around each domain, label it, and then write it down. I'm going to show you. I'm going to promise. We're going to do so many of these and be like, oh, this is easy. This is a breeze. Lillian, go ahead. Okay? So, does this make sense? Let's look at the next one. Let's go down. So HS2. All right. Does everyone agree that is the shape, the Lewis structure of this molecule? All right, everybody okay with that? So again, what do you draw a petal around? An atom or a lone pair? How many atoms are bonded to this thing? 2. How many unshared pair are around it? 2. Brianna, what color flower petals do you want? Blue. Okay. All right. So, does that get a petal? Does that get one? Does that get one? Does that get one? Yes. Again, why did those pairs get them? They're lone pairs on which atom? The central atom. So my question to you is, now we label it. How many did I use? Did I use an S pedal? Yes. Did I use one P pedal? Did I use another one? And did I use another one? Did I use any D pedals? No. The reason I didn't use any Ds is because there was 4 pedals, there's 4 things. So what's the hybridization? Does that make sense? Mackenzie, go ahead.
So say for the long pair on the 8.
Don't get ahead of me. Don't get ahead of me. But to answer your question, it's only on the, oops, that's the wrong button. It's only on the central, nothing on the outside. Okay. All right, let's go down to the next one. And Mackenzie, this will make your question make even more sense. Okay. So does everyone agree that that is the structure that you have? Okay. All right. So S, let me make it a color you can see. S, P, 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 1, 2, 3, 4, 5. All right, now, this is an important question. What type of bond is between the carbon and the nitrogen? This is a very important question. Does that triple bond mean still only one petal or 3 different petals? Just one. Okay. If it were a double bond, would it be 1 petal or 2 petals? 1. So does the bond type matter? Not at all. The next important question, Mackenzie, gets to your point. Does the lone pair on the nitrogen get one? No, because it's only the lone pair on which atom? The central. All right. So let's draw. Lily, what color or 5 pairs do you want? Pink. That pink? Bright pink or light pink? That one. All right. So does the H get one? Does N get one? Is there anybody else that needs a petal? So what did I just use? Which orbitals did I use? Did I use the S?
Yeah.
How many P's?
1.
So what's the hybridization? S, P. Now, I get every year. Do I have to put the 1? I don't care. You can put it or not put it. Doesn't matter at all. Question. Why is it not SP2?
That's what I was thinking.
Because I only had an S and I only had a P. That's it. I only used one S and one P.
Okay. The central atom is not considered the P. Wait, that isn't, never mind.
You with? Does that make sense though? Did you answer your own question? Okay. Everybody go with this? All right. Here's what I want you to do. I want you to flip over. Actually, no, let's just do the last one, just to make it all make more sense. Okay? All right. So 1, 2, 3, 4, 5. So S, P, P, P. That's the wrong letter. Let's try this again. 1, 2, 3, 4, 5. Okay. All right. Mackenzie, what flower petal? What color? Red. Okay. All right. Again, what do you draw a petal around? Bonded atoms and unshared pair around the who? The central. So how many flower petals is the thing going to have? So 1, 2, 3, 4. Does everyone agree with that? Did I use an S petal? How many P petals did I use? 1, 2, 3. Did I use any D petals? So what's the hybridization? S, P. Do you all agree this is really simple? All right. I'm going to show you 2 more. Go ahead, Gabriel.
Never mind.
Okay. Flip over and let's do PCl3. All right. Katarina, what color flower petals do you want? Say again? Gray? Okay, that's why I asked you. Gray flower. All right. All right. How many flower petals are on this thing? How do you know it's 4? There's 3 atoms and 1 lone pair. So I've got this, that, and that. What's your, it does like a squid. What's your hybridization? S, P, what? All right. I'm going to do one more. And this is not on the sheet, But if you've got space anywhere on the page, I do want you to draw it. And this, well, I'll explain it afterwards. All right, Carolyn, what color flower do you want? Orange. Love it. All right. First and foremost, what is the formula to this big old thing? First, SF6. That makes sense? All right. Now, again, how many petals is this thing going to have? 6 petals. Does everyone agree with that? So let's draw it. 1, 2, 3, 4, 5, 6. This is when the flower thing clicked. I was drawing this one day in AP, and I randomly did this. And someone said, that looks like a flower. I said, oh my gosh, I figured it out. I found the key that unlocked hybridization. So ever since then, this is how I've always taught it, never had any issues. Okay? So, but now we've got to assign a hybridization. And the reason I did this one is for this reason. So we've got S, P, 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 D, 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 and D. All right. So, do you agree I've got to label these? Now, this is a big one, so I'm going to write them all inside of it. So, is that my S? Does it matter where the S goes? No, you just got to label it. So, that's that. Am I going to use 1, 2, or all 3 P's?
All 3 P's.
So, P1, P2, P3. So, I've taken care of all of those. Do I have any D petals? How many?
2.
So, what is the hybridization?
SP3, D2.
That's it. That is the most complicated hybridization can possibly be.
How?
Okay? So this is it. This is as hard as it can possibly get. So if you have your Vesper theory sheet out, if you'll flip it over, and if you don't, that's fine, but I want to point something out. For a single atom, the most possible bonded locations that an atom can have is 6. So for a single atom molecular structure, this is as big as it gets. There is nothing bigger. What is the shape name? Octahedral. What is the bond angle of an octahedral? 90 degrees. So this is how I want you to picture it. Imagine you standing in the center, and you have 4 out like this, and you have 4 out like this. And then your head is 1, and your feet are 1. And it's 2 triangles stacked on top of each other. Does that make sense at all? This won't work either. Not triangles, pyramids. I won't try to draw it. But the whole point is it's like it's a pyramid with the point, and then there's another pyramid on the bottom. With the point.
Okay.
So it's like it's got a square base, and it's got a point at the top, and it's got a square base and a point at the bottom. That's what that looks like. Okay, so everything's 90 degrees. So with me saying that, since that is the most complicated it will ever be, is it possible to have anything greater than D2? That's it. It can never be larger than that. So if you ever write D3, you've done something wrong. Okay? That's as large as it is. Can you ever have a P4? No, because there aren't 4 p orbitals. There's only 3 p orbitals. Yes, sir. Never mind. Okay. So let's do one more. Yes, ma'am.
Are we going to have one of these like on the test?
One of these shapes? No. There will not be any of the shapes that are on the back of that Vesper theory sheet. All of the shapes. But the reason I showed you this was 1, can you do the hybridization? Number 2, this is where my flower petal thing came from. It was just literally a happenstance, and it's worked flawless ever since. Let's do one more, just to see if you can do it, and nobody say anything out loud. I want to give everyone a chance to see if you can mentally picture it with all the petals, then label the petals, and then see if you can give me the hybridization for this thing. Don't say anything out loud. Give everyone a chance.
Like different page or something?
Sir?
Is this like supposed to be different or something?
This one's different than the last one, yes. The reason why is there's 1 less atom. What's the formula for this? This is, no, the formula. PCl5. Does that make sense why this is PCl5? All right, Karen, what color flower petals do you want? Karen?
Hot pink.
Hot pink. So that one right there?
Yes.
All right, so 1, 2, 3, 4, 5. So what's the hybridization? SP3D. Now, if you want to throw the 1 in, that's fine. Doesn't matter. SP3D. So is everybody comfortable with hybridization? That took me less than 10 minutes. That's it. We're done. Like, that's it. That is it for hybridization. So what I want you to do, just to make sure you're right, I left 4 more on the back. See if you can do the last 4. I'll give you the answers really quickly. Just, again, it's the 4 that I didn't do. SF2, CH3Cl, CH2S, and SCl2. Take about 2 minutes or less. Just do those hybridizations. I'll throw them up on the board just to confirm you got it right. If you got a question, now will be the time to ask. And then basically what I'm going to do is I'm going to turn the rest of the class over for you to do whatever you need to do to prepare for tomorrow. Whether it's work those 23 Lewis structure problems and ask questions, whether it's to watch a video that you've missed, whatever you need to do for tomorrow to be prepared. Yes, sir. You got a question? Give me 2 seconds, okay? Yes, ma'am. Do these and we'll let you go. All right, so let's look at these real quick. So first and foremost, I'm going to do the 4 on the back, but we need to go back to the front and have a very, very deep and important conversation about HI, and we'll get to that in just a second. So let's look at H2S. Do you agree that this top left one is the shape you should have had? Okay. Destiny, what color flower petals do you want? Green. Okay. So S, P1, P2, P3. So this should be SP3. Everybody good with that? All right, Jamia, what color flower petals do you want on the bottom one? Yellow. All right. S, P1, P2, P3. So this should be SP3. Everybody okay with that?
Yeah.
All right, Emily, what color flower petals do you want? Purple. Dark or light? Light. Okay. Now, again, I'm going to pause on this one. Do those double bonds count as 1 or 2? 1. Did those S's get their own flower petals? No. So it's S, P1, P2. So it is SP2. Did everyone get that one? Go ahead. Hang on, Karen. Say again. So it's only on the central atom is when they count. So come back over here. Are those on the central atom? Over here. If they are on the central, they do count. If they're not on the central, they don't count. Okay? All right. Ayana, give me the last one. Which thing? What color? Light pink. All right. So did those count for petals? Because they're on the central. So 1, 2, 3, 4. So this is SP3. Everybody get those? Do you agree this is really simple? Okay. I told y'all this is easy. The last one we need to deal with, and Jordan, you can agree or disagree. We had a long conversation about this, and the problem is that everyone overcomplicates this. I don't want you to think about chemistry. I want you to think about reality and what is the actual right answer. H or I is in the center.
I.
Jordan, which one's in the center? Neither. You can't have a center between 2 things. There's not a center atom between the 2. The bond is the center. So here's how we do this. You pick one and you draw 1 petal. So here's what students want to do. Because the rule I always say is what can't be in the center? H. So people say, okay, well then that's it. Well then what they do is they come in and say, well then those and those and those. I understand that concept. But the reason we can't do this is because is there a center atom? No. So what you have to do is you have to look at it from either perspective. If you start here, there's 1 petal and it's just S. If you start here and do 1 petal, it's just S. Does it matter? So if it's two atoms, the hybridization is automatically what? S. Let me give you another example. This is on your 23 question homework problem. Let me ask the exact same question. Which atom is in the middle?
Neither.
Neither one of them. So what is the shape of this?
Linear.
Linear. Bond angle? 180. Polar or non-polar? Non-polar. IMF? LDF only. Right? Now you don't have to write the word only, but it's LDF only. Hybridization? S. You are done. That's it.
So it's like.
That's it.
It's
That's it.
always S.
Only when it's two atoms. Because there's nothing in the center, right? Oh, okay.
Sorry, that's
Okay.
so far for a
All right. Any questions on this? All right. So again, now is what I want you to, and I'm fixing to rewrite the rules for IMS just so you can have them in front of you. So as you're going through it, that's fine. If you need to grab a Chromebook, that's fine. Whatever you need to do to work towards tomorrow. So I'm going to write the rules for IMS on the board. I'll send it to you. All right, so let me make sure that everybody understands IMS very quickly. So again, when you're drawing these things, it's very simple to attach this to it. So once you've established if a molecule is non-polar, what do you instantly write for the IMF?
LDF.
That's it. It can only be LDF. If you establish it as polar, it's LDF and. You then have to make a decision. If it's and, it's either dipole-dipole or hydrogen bond. Now, the easiest way to determine is it hydrogen bond? If yes, it's hydrogen bond. If not, it's automatically dipole-dipole. But there's three qualifiers for the hydrogen bond. At minimum, what does it have to have? It's got to have a hydrogen. If it doesn't have a hydrogen, it can't be a hydrogen bond. Number two, what are the three other elements it must have? F, O, or N. Fluorine, oxygen, or nitrogen. Then the third key component is, what must the F, O, or N also have? A lone pair. So if it doesn't check those three boxes, if one of them is not checked, it is automatically a dipole-dipole. So again, I'm going to leave that up so as you're working through these problems, it'll help answer any questions you may have. Okay?
All right, Mr. Richards, what's the electronegative out of cesium and hydrogen?